Hello everyone, and welcome back to my channel. In this video, we will see how to make simple touch sensors, using common objects. These sensors can be used, in place of switches and buttons, to provide inputs. Let's get started. Among the many accessories that can be connected to Arduino, we find these capacitive sensors. These devices are operated by simply touching them with a finger, and can be used, instead of common buttons and switches, to provide inputs to the equipments. In this video we will see that it is possible to make similar sensors, without the need for any specific hardware. In fact, taking advantage of some of the Arduino's internal features, we can use common objects as sensors. Compared to commercial sensors, and also to common switches, in this way we have the advantage of using only one wire for each sensor, as neither power or ground connection is required. So let's see a quick explanation of the operating principle. The object used as a sensor physically constitutes a capacitor, with its own specific capacity, generally of a rather low value. Touching the sensor, the capacity varies. By keeping this value monitored, which can be done in several ways, it is possible to detect the moment in which the sensor is touched. Among the various systems that can be used for this purpose, one of the most interesting is that of the capacitive voltage divider. This method is described in some application notes from Microchip, and consists in charging the capacitor represented by the sensor, and that of the analog to digital converter present in the microcontrollers, at known values. The two capacitors are then connected together, and the voltage across them is measured. The value of this voltage is a relative indication of the sensor capacity. After using this system in some projects with PIC microcontrollers, I decided to try to implement the same technique on Arduino. Before continuing with the description, I would like to say that there is already an Arduino library based on the same operating principle. Unfortunately, this library implements the method described in the Microchip application notes only partially. The complete method, in fact, that I use in this project, consists in carrying out the reading of the sensor in two stages, charging the capacitors with opposite polarities from time to time. In this way, the useful value is obtained from the difference between the two measurements, in order to get more significant and reliable results. Porting this technique to Arduino was not an easy task, for two reasons. First of all, some aspects relating to the analog to digital conversion module are not very clear from the data sheet of the ATmega 328, so I had to make some assumptions and even some practical tests, which however still left me with some doubts. Secondly, for optimal operation, this technique would require the use of assembler as a programming language. Unfortunately, I know the PIC assembler quite well, but I'm not as familiar with the Atmel processors, so I had to fall back on the normal Arduino-like C++ development environment. In the end, however, the results were quite satisfactory. Keep in mind that this is a simple experiment, born for didactic purposes rather than for practical use. In the video description, you will find the link to the firmware for the project. Obviously, it is a simple demonstration program, which you can take as a starting point, to study its operating principle, and possibly adapt it for some practical application. For each sensor that we intend to use, we need a variable of type touchpad, that is a data structure whose definition we see here. After declaring the variables, they must be initialized with the touchpad init function. This function required two parameters: the address of the variable itself, that is the name of the variable preceded by the ampersand symbol, and the pin to which the sensor is connected. The pins that can be used for the sensors are the analog ones, ranging from A1 to A5. Terminal A0 must be left free, because it is used for the measurement process. This pin must therefore remain disconnected. In the main loop, the sensors are continuously monitored via the touchpad scan function. Obviously, for a quick response, the scan must take place at fairly close intervals. After scanning, the status of the sensors is used to turn the corresponding LEDs on or off. There are two ways to do this. In the touchpad structure, there are two members, state and toggle state. The first represents the instantaneous state of the sensor, that is 0, in normal conditions, or 1, if you are touching the sensor. You can therefore use this value as the reading of a normal momentary button. The toggle state member, on the other hand, changes state each time the sensor is touched, passing alternately from state 0 to state 1. In this way the operation is similar to that of a switch with two positions, on and off. Let's now see the circuit, which as you can see is very simple. There are only 4 LEDs, connected to Arduino terminals through 330 ohm resistors. The sensors, as we have seen, must be connected to the analog terminals A1 to A5. Please note that pins A6 and A7, available on the Arduino Nano, cannot be used to connect other sensors, so the maximum is 5. In fact, I remind you that pin A0 must remain disconnected. And this is my prototype. For the sensors I simply used pieces obtained from a printed circuit board. Just for demonstration then, I made a fifth sensor using a €2 coin. For an optimal result I recommend you to isolate the sensors with a piece of insulating tape. In this way the operation will be much more reliable. I will now load the firmware. And here they are, 5 beautiful sensors at no cost. As it is, the firmware works quite well using the most disparate objects as sensors. If it does not work as expected, you can try to modify the 2 macros found at the beginning of the program. The first represents the threshold, that is the sensitivity. If you notice that the sensors are not responding, you can try to decrease this value a little. Samples, on the other hand, indicates the number of readings that are made for each sensor measurement. You can try to increase it if you notice that the sensor has a somewhat unstable response, for example if the LED tends to turn on and off several times when you touch a sensor. If you want, you can also enable the transmission of sensors measurements via the serial port, simply by decommenting this line. In this way you can use the plotter present in the Arduino IDE to check the operation and response of the various sensors, which is very useful for testing. Okay guys, that's all for this video. If it has been useful to you, please put a like and also subscribe to my channel if you have not already done so. In the meanwhile I greet you and give you an appointment to my next videos. See you soon.